The OSI model is a simplified way to understand a complex process of how data travels by breaking it down into 7 steps. It's a great tool for anyone who wants to know how the internet or any network really works. TCP/IP, on the other hand, is a set of standardized rules that computers understand when talking on the internet. Think of it like a language everyone uses to communicate so that machines can understand each other, regardless of where they are or what type of computer they are using. Imagine you want to send a funny cat video to your friend across town. The video travels through a complex network of wires and towers, kind of like a relay race. The OSI model is a way of understanding how this data travels by breaking it down into 7 steps. It is a conceptual model that divides network communication into 7 layers. Think of it as a blueprint for how network communication should work. Each step handles a specific task to get the video to your friend. Here is the breakdown of OSI layers. Layer 7 or application layer is where your fun begins. This layer is like the starting line and closest to end users. Here, applications like your web browsers or video player talk to the network. It figures out what kind of data you are sending, such as a video, and prepares it for the journey. This layer also defines protocols for end applications. Layer 6 is the presentation layer. Think of this as the translator. It gets the data ready for the receiving device to understand. It might change the format or compression of the video depending on your friend's device. For instance, it can transform a text file encoded in EBCDIC to one encoded in ASCII format. It functions for data compression and encryption as well. For example, video calls will be compressed during the transmission so that it can be transmitted faster, and the data will be recovered at the receiving side. Data that demands high security, like text message containing your password, is encrypted at this level. Layer 5 is the session layer, and this layer sets up the connection between your device and your friend's device. It's like two friends making sure they are on the same channel before they start talking. Layer 5 software also handles authentication and authorization functions. It verifies the data is delivered as well. The session layer is commonly implemented explicitly in application environments that use RPC or remote procedure calls. More on RPC in my future videos. Layer 4 or transport layer is where the things get moving. This layer breaks the video into smaller packets like cutting a pizza into slices. It also adds labels and checks to make sure all the slices arrive and in the right order. Popular protocols here are TCP or Transmission Control Protocol and UDP, User Datagram Protocol. Layer 3 is the network layer, and this layer is like the post office. It figures out the best route for the packets to travel and adds addressing information like zip codes. This lets the packets find their way to their friend's device. A network is a medium to which many nodes can be connected. Every node has an address. When a node needs to transfer a message to other nodes, it can merely provide the content of the message and the address of the destination node. Then the network will find the way to deliver the message to the destination node, possibly routing through other nodes. If the message is too long, the network may split it into several segments at one node, sending them separately and reassembling the fragments at another node. Layer 2 or the data link layer is the layer focusing on getting the packets to the next device on the network, like router or switch. It defines the protocol to establish and terminate a connection between two physically connected devices, such as point-to-point protocol or PPP. The data link layer is generally divided into sub-layers: the media access control layer and the logical link control layer. The MAC layer manages device access to network media and grants permission to send data. The LLC layer identifies and wraps network protocols, overseeing error checking and frame synchronization. Think of it as the traffic cop of the network, determining who gets to send data and when. The LLC layer sits above the MAC layer and focuses on the logical organization of data. It handles tasks like identifying different network protocols such as IP or IPv6. The LLC layer basically handles the organization and integrity of the data being transmitted over that medium. And finally, layer 1 is the physical layer. This is the most basic layer. It deals with the physical transmission of the data like electric signals or light pulses traveling through cables or wirelessly. The physical layer is the foundation of any networking infrastructure. It operates independently of the higher layers and serves as the medium through which raw bits are transmitted and received. At this layer, the focus is solely on the physical characteristics of the transmission, ensuring that the data is sent and received accurately over a physical medium such as copper cables, optical fibers, or wireless channels. By working together, these 7 layers ensure your funny cat video gets to your friend in one piece, ready for them to laugh. Note that in a layered system like this, devices of a layer exchange data in different formats, which is known as Protocol Data Unit or PDU. The table below shows the PDU in different layers. So when a user requests to browse a website on the computer, the remote server software firstly gives the requested data to the application layer, where it is processed from layer to layer down with each layer performing its designated functions. The data is then transmitted over the physical layer of the network until the destination server or another device receives it. At this point, the data is passed up through the layers again, each layer performing its assigned operations until the data is used by the receiving software. During the transmission, each layer adds a header or footer or both to the PDU coming from the upper layer, which directs and identifies the packet. This process is called encapsulation. The header and footer and the data together form the PDU for the next layer. The process continues until reaching the lowest level layer, which is the physical layer or the network access layer, from which the data is transmitted to the receiving device. The receiving device reverses the process, de-encapsulating the data at each layer with the header and footer information directing the operations. And then the application finally uses the data. The process is continued until all the data is transmitted and received. Understanding the concept of layer division enables us to pinpoint the sources of connection issues more effectively. Instead of starting at the top layer, it is advantageous to begin troubleshooting from the bottom layer. Each layer supports the one above it, simplifying the resolution of lower level problems. For instance, if your computer experiences internet connectivity issues, the initial step is to verify whether the network cable is securely plugged into your computer. Now, the OSI model is a theoretical framework for understanding how network communications work. TCP/IP is one of the practical sets of protocols that make this communication happen in the real world. The TCP/IP protocols were developed in the 1970s by the US Department of Defense as a way to connect different computer networks. It was a practical solution that became the foundation of the internet. The OSI model was developed later in the 1980s as an attempt to create a comprehensive standardized framework for all types of network communication. It aimed to create a universal language for describing networks. However, the OSI model was complex and many companies found it difficult and costly to implement. And TCP/IP was already widely used and proven to work for the internet. It was a tried and true tested method. So even though the TCP/IP model was developed before the OSI model, we usually learn about OSI model first because it's a helpful way to understand the concepts of network. TCP/IP is the language of the internet. It is a set of standardized rules that computers understand when talking on the internet. Think of it like the language everyone uses to communicate so that machines can understand each other, regardless of where they are or what type of computer they are using. TCP/IP handles specific part of OSI model. It mainly focuses on layer 3, which is the network layer, and layer 4, the transport layer. TCP itself stands for Transmission Control Protocol. It breaks the data into packets like the cat video and ensures they arrive in the correct order. Think of it as a reliable mailman who guarantees deliveries and assembles a package carefully. It's great for things like web browsing, where ensuring no data loss is crucial. IP stands for Internet Protocol. It focuses on addressing and routing the packets, like putting the address on an envelope and sending it on the best path. The OSI model is a theoretical framework, like an architect's blueprint for building. It describes 7 ideal layers of how any network communication should work, providing a reference point for understanding. It helps us visualize and understand communication networks, even though real-world systems don't always perfectly follow it. The TCP/IP model is like the streamlined version of the OSI model, focused on how the internet actually works. It combines some OSI layers and has 4 main layers: application, transport, network or internet layer, and link or the network access. The TCP/IP model roughly aligns with the OSI model, but the layers don't match up perfectly. As TCP/IP developed, it made more sense to combine some functionalities that the OSI model kept neatly separate. For example, in the OSI model, the presentation layer handles the looks of the data. It is responsible for converting data formats between different systems so they can understand each other. For example, different image formats or character sets like ASCII. In TCP/IP, the concept of presentation is mostly handled within the application layer or specific protocols at other layers, where each application, like our web browser, might handle its own data formatting, encryption, and compression. TCP/IP clearly combines some of the OSI layers. The presentation and session layers from OSI don't have a direct equivalent in TCP/IP. Their functions are partially handled within the application layer or other parts of the model. The data link and physical layers in OSI become network access layer in TCP/IP, focusing on the physical process of putting data in the network. Now, TCP/IP protocol suite is the collection of actual protocols used in communication on the internet. These are the working instructions and tools built around the TCP/IP model. Here are some of the important ones within the suite. TCP or Transmission Control Protocol for reliable ordered data delivery, IP for addressing and routing packets, HTTP for web browsing, FTP for transferring files, and SMTP for sending emails. Basically, OSIModel is the recipe for how to bake any kind of cake, whereas TCP/IP model is a specific recipe for how to bake a chocolate cake. TCP/IP protocol suite consists of the ingredients such as flour, sugars, eggs, TCP, IP, etc., and tools such as measuring cups, oven to make the chocolate cake.